My name's Nikki. Hopefully you're having a good reInvent so far. It is Wednesday. Happy hump day. How many people are still running low on energy? Wednesday? Me. Hopefully you had enough coffee this morning. So I am a senior software engineer here at AWS. I work on the Amplify team. So typically I work with mobile applications, but I have a deep passion for serverless, and I was an evangelist only 2 months ago. So I had my hands in a little bit of everything. And I've been developing serverless applications since 2014, since the launch of Lambda. So I put together this talk as a collection of things that I've learned along the way, either by trial and error, let's just emphasize trial and error, or learning from my colleagues, or just studying. This topic is actually very esoteric, as I've come to find, is that there's not a lot of good content online when you run into a problem with networking when you're developing a serverless application. So it is a little bit of an eclectic collection of stuff that I'm going to walk you through. But hopefully you can walk away with something and learn something today. I definitely know that there's probably people out here that know more than I do about networking in general or just anything. So hopefully you walk away with at least one new thing that you didn't know. I will also preface by saying this is a 400-level talk, so I won't be going into every single definition of the basics of AWS networking. So if that's something that you need, I won't be offended if you need to excuse yourself, or maybe just hearing it for the first time and then looking it up later might work for you. Feel free to stay if that's what you want to do. And then the last thing I'm going to say is that I typically don't talk very slow. It's very hard for me. Usually, my mouth can't keep up with my brain. That's just me. And no, I'm not from New York, but you'd think I was. So I'm going to try to talk as slowly as possible because the content today is very heavy and some of it's complicated. And if you haven't heard it before, it might be confusing. So I'm going to do my best to talk as slow as I can. And I'm going to pre-apologize to anyone in the audience that's like me that doesn't like it when the speaker talks slow because I have like the attention span of a squirrel. So will try to talk as slow as I can. Any luck? Cool. This happened to me yesterday. This is, I think something's with my voodoo or something. I just touch machines and they break now. Okay, well, sorry about that. So, what? Are you a chaos monkey? I don't know, man. Every time I've touched one of those boxes, the thing has just crapped the bed, so. Let's hope that this doesn't continue because I have another breakout after this. So this is a repeat. I did this talk on Monday. Nothing actually went wrong on Monday, so maybe it was just yesterday that it started. It is being recorded as well, so you will be able to watch it online if you need to hear things again. And also, because it's very complicated, I feel like I have about 45 minutes of content, so I'm going to do questions. These mics here are for questions at the end. Feel free to come up to the mic and ask, and just make sure when you come up to the mic that you eat the mic so everybody can hear your question. OK, we're in. OK, so this is networking best practices for serverless applications. Here's some related breakouts. Obviously, this top one was on here because I did this Monday and wasn't able to remove it. But some of these related breakouts, my friend Eric Johnson, he's doing a talk on, I didn't know Amazon API Gateway did that. It's a really cool talk. He's a really good speaker, so I highly suggest you check him out on Thursday. We talk about some of the same things, but he goes more into depth. So if you are interested, I highly suggest attending his talk. And then, security and networking go hand in hand. So I threw up a security talk up there in case you're interested. OK. So today's agenda. So we're going to talk about Lambdas in VPCs, and I'm going to do a very, very short demo, just to demo some of the cool new things that we've launched recently. And then we're going to do best practices for private and public API gateway projects. I think the networking complexity gets very complicated when it comes to private API gateway projects, so I'm going to spend a little bit of time on it to try to help you understand the different use cases and different things that could happen to you along the way. And then I have a miscellaneous category of just, something I didn't quite know where it fit, but I still thought it was relevant to networking. All right. OK, so Lambda and VPC. So when should you do it? Well, you should only do it when your Lambda needs to talk to something in your VPC. And I also want to clarify one piece of information. So we consistently say, put my Lambda in a VPC. Well, we're not actually putting a Lambda in your VPC, right? The Lambda lives in a service-owned VPC, and you are essentially making some kind of attachment or connection to your VPC. And we're going to talk a little bit more in depth in that in a couple of slides. But I know that these slides can be extremely deceptive because we constantly do things like this, where you see the Lambda is in the VPC. So I just want to clarify right up front that some of my visuals or diagrams are deceptive in this way. But now that you guys know the truth, if you didn't know it before, it's just for a visual representation, so you can understand conceptually that the Lambda is attached to the VPC. So you should only do it when your function has to talk to something inside your VPC. Okay, so question, how do I get the best performance? And also, how does it work behind the scenes? What's really happening when I attach my Lambda to a VPC so that I can thoroughly understand what things I need to do to make sure that I have the best security, the best performance, just make sure I know the basics. So let's talk to some recent performance improvements. So a couple months ago, we launched this, and I wanted to go over it because I wasn't sure if everyone has seen this launch, and it's extremely important to understanding how Lambda works when you attach it to a VPC. So in the old ways, before like 2 months ago, I think it was like September when we launched this, every time you attached your Lambda to a VPC, when you executed your Lambda, it would create an ENI and attach it to make that network tunnel to your VPC. Now that takes a lot of time, right? Those dreaded cold starts, we all know them. They take forever. It takes so long because it's literally sitting there creating it and attaching it. That's the old way. The new way basically maps your VPC to a hyperplane ENI and then to an ENI in your account. But there's a couple key differences here, which is that the ENI in your account is not created at the time of execution. It is created at the time of creation of your Lambda function or when you add VPC settings to it. So like right now, if you went into your console and you changed the VPC settings, you attached it to a VPC, that's the moment when the ENI gets created in your account. So this obviously creates a huge difference in the performance because then now when you execute that function, it can just create a network tunnel to the existing or pre-created ENI, and you don't have to wait for it anymore. So this has drastically increased the speed in which your Lambda executes and also decreased the duration, obviously, so latency has decreased. In addition to that, it's important to understand that every unique security group and subnet combination across the functions in your account require a distinct ENI. So this is another huge difference. You may have run up against ENI limits before. Let's say you had a lot of functions executing concurrently, and your account is limited by how many ENIs that you can create. And so your scale of your Lambdas are limited, or your scale of your serverless application if it's the same function. Well, now the way it works is that each unique security group and subnet combination across functions will require a distinct ENI. So that means, in this example, if these three functions share a unique security group and subnet combination, they can actually use the single ENI in this image, and they do not need to share multiple ENIs, which means that you are not now limited by the number of ENIs that your account can create. You don't have those limits anymore because now ENIs can be shared across functions across your account. Okay, so let's see why that really matters. Well, that's a huge freaking difference, right? We all want to see the numbers here. We want to see what does that really mean? Okay, you told me how it works, but how does that affect me today? So I'm actually happy to announce that this is actually public now in all commercial regions across AWS. So none of our private regions, but all of our commercial public regions, this is live. And if you haven't taken a look lately at your functions, if they are attached to VPCs, you should take a look, because I bet that there's a serious decrease in the time it takes to execute them. Some guy on Monday came up to me and showed me a graph of his functions, and they were like, all these high execution times, and then you just see this massive drop. And I was like, that's so cool. He was like, I'm framing this. So this is obviously one function, right? But it went from 14, almost 15 seconds to 903 milliseconds. And this is Mun's function. So you'll see I will give an example of my function and how fast it executes. Obviously, it depends on what the code is doing and how you're using the function. But there is still a drastic difference between the durations here that I wanted you guys to take note of. And so hopefully you've already taken advantage of this in your accounts. Okay, so what didn't change? Well, this is important because we have to know what didn't change so we can still think about the things that we need to worry about and think about the things that we need to set up and account for best practices for when attaching our Lambda to a VPC. Well, IAM permissions didn't change. You still need to have a role that's attached to your Lambda function that can create and delete ENIs. You still have to have that. It's not going anywhere. The config, you still control the subnet and security group configuration of these ENIs. So you should still continue to apply normal network security controls and follow best practices for VPC configuration. And lastly, you still need a NAT gateway or a NAT device to give your function internet access, or use VPC endpoints to access services outside of your VPC. But nothing changes about the types of resources that your functions can access inside of your VPCs. Okay, so let's talk about some best practices. So the first thing is, if your function does not need to talk to anything inside the internet, you always want to put it inside of a private subnet. And in fact, generally speaking, even if it does need to talk to the internet, you should still put it in a private subnet with a NATed route to the internet. So you can see here, the Lambda function is sending traffic to the route table, and the route table is then forwarding that traffic to the NAT gateway, and the NAT gateway is then sending the traffic out to the internet gateway, and the internet is receiving the traffic and has the elastic IP, the NAT elastic IP as the source IP for the traffic. So this path is the NATed route to the internet, and it is definitely a best practice. So you should still put your Lambda in a private subnet, even if it needs internet access. Okay, let's talk about VPC endpoints. So VPC endpoints are actually special endpoints, if you're not aware. I will define this one for you, that are offered by AWS that enable you to privately connect your VPC to some of our supported AWS services without requiring an internet gateway, a NAT device, a VPN connection, direct connect connection, none of the above. So there are several services that offer VPC endpoints, and there are two kinds. They're interface and gateway. An interface endpoint is essentially an elastic network interface. So you can see here it's hosted by AWS Private Link. Well, what Private Link is, it's an elastic network interface with a private IP address from the IP address range of your subnet that serves as an entry point for the traffic destined to that service in the service-owned VPC. Some of them I plotted here for you, so you can see I basically just plotted all of my favorite services that are supported by interface endpoints. There are a lot more. You can check them out at this link here. But yeah, these are the ones I most commonly use when it comes to developing serverless applications. So I just showed you here which ones are supported by interface. Now we have gateway. So gateway is a gateway that you specify as a target for a route in your route table for traffic that is destined to one of our two supported services for gateway endpoints, which are DynamoDB and S3. So you should always be using VPC endpoints when you can, especially when your Lambda needs to talk to any of these services that are supported. Okay, so we're going to do a little demo. It's like very tiny, nothing complicated. I want to get back to the content here. Let me just log in. I just wanted to show you really some of the performance improvements that I just talked through. So I have this Lambda here. It's not complicated at all. All it's doing is it's hitting parameter store to grab a parameter under the URL/messages and just dump it out and print it. That's it. There's nothing complex about this Lambda. Now, here's where the fun gets in. I've deployed this already. Didn't want to waste anyone's time. And I have attached my Lambda to a VPC. So you can see that here. And I also, let me get rid of this, created a VPC endpoint. So we just talked about them. I created an interface, VPC endpoint, for SSM. So you can see that here. You create them by service. So now, when I actually run this Lambda, it's going to use the VPC endpoint to hit parameter store. Just watch how fast it goes. That's all I really want you guys to see. So look at that. It's crazy fast speed. That never would have happened before. We would have been here for a lot longer. So I just wanted to show you that this is already happening in all these accounts, and just to make sure that you're taking a look at your accounts and seeing that your functions are already taking advantage of this performance improvement. All right. Let's get back to it. So now we got to talk about more complicated things. This is where it gets fun. Private API gateway. Okay, so setting up a private API gateway can be difficult. So let's get into some real use cases, or what happens as we go on our journey. So this slide is very complicated, but I'm giving you this slide just to give you an overview of the different endpoints that you can create with API gateway. So there are 3: private, regional, edge optimized. So if you pay attention to the right side of the slide, these are all the front ends, right, of what could possibly be hitting these endpoints. And if you notice, the private one, which is what we're going to talk about, the front end is a VPC. So my actual front end isn't what I normally think of here. It's not a device or a web app. It is a VPC that needs to hit this private endpoint. And this is where things get complicated. So how do I do this? Well, in order to access my private API gateway endpoints, I have to create VPC interface endpoints. API gateway is supported by VPC endpoints. And then once I create the endpoints, though, they're not actually specific to the API gateway project. So in this scenario, I have a pets API and employee API, right? I have 2 different API gateway projects. Okay, how do I tell my endpoints which project that I'd like to hit? Well, you just saw those endpoints, and I said that they were created by service, right? So I can create multiple endpoints, but they're for the whole service, so all of API gateway. So this is where DNS names come in. And when you provision the VPC endpoint, you have an option to check a box to enable private DNS names to on. Now, behind the scenes means we're creating a private hosted zone mapped to that VPC that will send anything to those endpoints. So the really nice thing here is that if you leave it on, you can actually just hit your APIs the way you normally would. Cool, that was easy. You're like, Nikki, this isn't complicated. I'm following. Okay, wait. What if we need to turn it off? And you're like, okay, why would we need to turn it off? Because you just told me that that's how to make it easy. Well, we might turn it off if our VPC needs to talk to multiple different kinds of API gateway projects. So private, edge optimized, and regional. What if my VPC has to talk to those public endpoints and the private ones? Well, now it gets really confusing because any traffic that ends with that execute API, region.amazonaws.com is actually just going to be redirected to those VPC endpoints. So now it's getting really complicated. So we have to turn it off. Okay, so now we've turned it off. Well, now what do? We can no longer use that execute API domain. It's gone. Can't use it anymore. So we have to find another way to connect to those different endpoints. So we can instead use the publicly available domain that ends with VPCE that is used for endpoints. And it will use the VPC endpoint ID, the region, and the domain. And then we'll follow that with the stage and the method or the route, however you prefer to say it. But the thing is, even if we use this, the endpoints still have no idea which API project we're trying to hit. So now what do? Well, we add a host header. So now if we add a host header with the original URL, the one that Amazon API Gateway gave us, now the endpoint knows which project to direct the traffic to. Okay, cool. So we solved the problem. Well, now, what happens if we want to hit these private APIs from outside the VPC? So you have another VPC that needs to talk to this VPC and then hit those endpoints. We don't want to use the internet, so how do we do it? Well, the process is exactly the same using the DNS handoff. Those endpoints will need to reach the VPC, right, with that VPC ID endpoint address and add that host header. There is another gotcha here, though. What happens if the VPC is in the same region? Guess what? Won't hit those endpoints. It's not supported right now. That VPC has to be in another region and has to be hitting this VPC through cross-region VPC peering. So how can we solve this problem? So this only works. So what can we do to solve this? So now we've talked through like a bunch of different gotchas, right, of different things that I need to hit my private API gateway endpoints from my VPC, from outside my VPC, from another VPC in the same region, a different region. How do I solve all these problems to make sure that this is happening no matter where my private endpoints need to be hit from? Well, there's a couple things you could do. You could, add some logic to add the host header to some of those front ends, right, those VPCs. Or you could add some proxies in front of the endpoint to make it easier. And my best practice, or my personal opinionated advice, is to go this route, and I'm going to walk you through it, because you move the complexity from the front end, which there should never be a lot of logic in your front end if you think about it, but just because it's a VPC, you're thinking about a front end differently. You should move it to essentially what is the back end, right? So we're going to do that. So let's say the client is anywhere, right? This client is anywhere. It could be inside the VPC. It could be outside of the VPC. It could be in another VPC in the same region, a different region. It's anywhere. Okay, it doesn't matter where it is. It connects first to an application load balancer that I've set up. Whoops, sorry. Which front ends a bunch of proxies. Now, I've chosen Nginx in this solution, but you can choose any proxy server. It really doesn't matter. For me, this was just like easier for me to set up. And there's some really good documentation on how to set this up on Nginx's website documentation. But again, you can use any proxy server. So it's going to hit the ALB, then the proxies, then the endpoints, and then hit my specific API gateway project. OK, so let's walk through that flow. So first, the client connects to the ALB. And now, key point here, I can use custom domains. I couldn't do that before, actually. So I can use this custom domain I have, api.example.com, and I can follow that with the stage and the method. So it's first going to hit the ALB. OK, the ALB doesn't do anything, doesn't change it, doesn't do anything, just passes it on, forwards it to the Nginx proxies. Now we get here. So the proxies now have a bunch of rules deployed, and you can create these rules off of path or header if you so choose. I usually go by path, so I would be looking for something called /pets. And basically at the point where it hits a rule that says, OK, if it's ending in /pets, if the path ends this way, then add a host header with that specific Amazon API Gateway project URL. And now it sends it on to the endpoints. The endpoints know how to get to the API Gateway project and forward traffic on, just like we discussed before. So again, we've now moved the complexity from the client to the centralized networking environment, which again is always a best practice in my opinion. And again, if you had another API like we did before with employees, it's going to again follow the same route from the client to the ALB, forward onto the proxies, and then again use rules to find that path /employees, or you can use a header, whichever you choose. You can do it either way. OK, let's move on. I know that was like very complicated. It was private API gateway. We have some public API gateway best practices to talk through. OK, so we had two different kinds of public API gateway endpoints. They were regional and edge, right? Well, I just want you to be extremely aware of the fact that they have very different response times. And if you looked at that first diagram where I had that like big overlay of all the different API gateway like paths, you saw that Edge actually creates an AWS CloudFront distribution for you. Well, it actually adds time to the response time, as you can see here. So these are two different endpoints, but in both cases, regional beats them. Well, now you're like, well, why wouldn't I just choose regional all the time? Well, because you need to know the location of your client to choose regional. So if you don't know where your client is calling the API from, you're definitely going to want to go with Edge. But if you know, you want to choose regional. And there's a gotcha here. The gotcha is that if you're using serverless frameworks like SAM or any of the other ones, they actually default to Edge. So if you're creating a serverless application with one of these frameworks, and you already know your client location, make sure that you're following documentation to actually set these APIs that get created to regional, not Edge, because again, they default to that, and that's a longer response time for your customers. Okay, this is an awesome quote from my friend AJ, who, if you don't know him, he's the director of product management for AWS serverless applications. And he says, don't use Lambda to transport, only transform. Well, what does that really mean, right? Well, there are certain cases where you actually don't need to use a Lambda. And this can increase your performance and decrease the complexity of your networking setup. So let's talk through one of those use cases. So on the first line here, we have like a very common pathway, right? API gateway to Lambda to Dynamo. I've probably set this up thousands of times before. You probably have too. Well, you actually don't need that in this case if the data is not changing. So if I have an object and I'm just putting it in Dynamo and I'm sending it to an API gateway endpoint, which then forwards it onto a Lambda, which then dumps it into a DynamoDB table, I'm not doing anything here to the data. I'm not transforming it. I'm transporting it. In this case, what you might not know is that API Gateway actually has the smarts to deposit this directly in Dynamo. You can set up an API Gateway project with an AWS proxy service, and you can use a feature of API Gateway called VTL, which is a velocity templating language, to actually dump the object directly in Dynamo. And I do want to clarify here, I know that this diagram is slightly confusing. I did have a question last time. VTL is not a new service that you need to learn. It is just a template language, and it is a feature of API Gateway. So you can write that, you can use that language as like a mapping template to basically map the object directly from API Gateway to DynamoDB. So the only use case that we might need that first pathway for is if we were changing the data somehow, right? So if we're just dumping it, we don't need the Lambda, we don't need to increase our networking complexity, and this is actually 10 times faster. So, I mean, don't quote me on that exactly, but it is a lot faster. Okay, throttling. We gotta talk through throttling. So API Gateway has an account-wide level limit of 10,000 requests, okay? So that means that if you have, let's say, 3 APIs in your account, and number 1 is the most popular, number 1 could essentially suck up all of the requests and hit that account level limit before 2 and 3 even get a chance to throw in their traffic. So this is a problem, right? So we need to make sure that we're using throttling to prevent this from happening. Also, let's talk through like a little bit more beyond that limit. So we have 10,000 requests per second, but we have a 5,000 burst limit. So that's another thing we have to keep in mind. So if, for example, you're a caller or a client submits 10,000 requests in a 1-second period evenly, so 10 requests every millisecond, API Gateway would process all of those requests without dropping any, and everything would be fine because we hit that 10,000 requests per second evenly. Now, if that caller or client sends 10,000 requests in the first millisecond, API Gateway could only serve up 5,000 because that's our burst limit, and it would throttle the rest in that 1-second period. So we have a 10,000 requests per second limit and a 5,000 burst limit. So there's a couple ways to throttle your account, or throttle your APIs in your account, rather. So you can do, whoops, did I just do that? Sorry. You can add method level overrides to your different stages. So you can set them right at the method level for the different stages. And you can set them to override that 10,000 requests per second limit. But it's never going to essentially go over it. So if you set it to 11,000, you're still going to run up against that 10,000 limit. when I say override, I literally mean like it would hit that throttling first before it would ever reach that 10,000 per second, 10,000 requests per second limit. So that's one thing you could do. The next thing you could do is create usage plans for your different APIs. Now, wait, what's a usage plan? Well, a usage plan is basically when you designate through like API keys that get metered who can access what and by how much and how fast. So you can throttle the different usage plan levels. So let's say we have these 3 APIs, and we know that our users need to get the most traffic, right? And these other 2, you know, they have a lot less traffic coming in, or they should have a lot less traffic coming in. So we're going to throttle them extensively more. So maybe we'll give the user an override of 7,000 requests per second, and then we'll divide up the remaining 3,000 by partner and service, and just say, well, they're probably not going to be hitting these endpoints that much, and if they are, it's probably an issue, so we'll just throttle them at 1,500 requests per second, and that's probably fine. So that's one way to do it. So you can do this at the API level or the stage level. You can also throttle at the method level for a usage plan. So now in this example, we have the same user plan that's throttled at the API level or the stage level, the same service usage plan, but we have 3 calls in the partner usage plan, and we're going to throttle the get because, you know, we're just getting hammered for whatever reason on that get. Partners are just overusing it. I don't know why. So then you can throttle like method specific for that usage plan. Okay, so the key point here is that throttling settings are actually applied in a specific order. So first they're applied at the usage plan level, both method and API and stage. So usage plan throttling is happening first. Then they're applied at the method level, just the general method level, right, for that API. That was the first thing we talked about. And then they have that top level account of 10,000 requests per second. And also, if 10,000 requests per second does not sound good enough to you, you can submit an increase request to actually get that increased. You just need to talk to customer support. Okay, caching. This is another important thing. So we need to cache. We can take advantage of API gateway caching to actually cache path, headers, query strings, a bunch of different things to actually increase the speed of our responses to our backend or whatever API gateway is calling, and minimize the load. So also decrease the number of networking requests that are even being made through caching. You can set this up at the stage or the method level. So make sure you're taking advantage of it. Okay, miscellaneous. So you might already be doing this. You probably are. Maybe you built your own library. But in case you aren't doing this, I just wanted to note this, this awesome library that my friend Alex wrote. He wrote a caching library in Python for both parameter store and AWS Secrets Manager. So this is a very, very common practice that I see, especially when I'm talking to customers, is that I have a Lambda function, and I'm calling parameter store, or I'm calling secrets manager to get a value, to then use that value and do something with it. Well, you can actually cache those values to decrease the number of networking calls that your Lambda is making, and obviously increase the speed at which it's executing. So he wrote it in Python. I also found it that somebody had ported it to Go, which is really nice. If you needed another language, I'm sure you could port the library. You might already be doing this. I think I had a customer talk to me yesterday, and he had built his own custom library for this. So if you're already doing this, just a friendly reminder to be caching your secrets and your parameters that your Lambdas are calling to decrease the number of network calls. Okay. And then this is just a reminder that we have plenty of courses available on our AWS training site for serverless. Let's take questions now. If anybody has questions about any of the stuff that I've talked about, I'm happy to take questions now.